This group of objectives is all about recognizing chiral centers when things are not the same as their mirror image. And in some context videos, you will have seen how important that can be in living things, the chirality of a molecule. But now we're just going to learn the simple rules for identifying does something have a chiral center? And you need something in the middle with 4 different groups attached. If they're all different, it will be chiral. If 2 of them are the same, it won't be. The mirror image will be superimposable. So let's just look and see the groups. We start on the end of a molecule. They're 3 hydrogen. Not chiral. This one has 2 hydrogen. Those are the same. This one has 3 hydrogen. Not chiral. Again over here, 3 hydrogen. 3 hydrogen. None of those are going to be chiral. Let's look at this one in the center here. It's got a methyl group one way, an ethyl group another. Those are 2 different ones. It's got this Y-shaped part of the molecule. That's a 3rd different one. The 4th is that implicit hydrogen we don't see. So this here, we could highlight it as chiral, and we've got 1 chiral center. Let's look at this one. It has 2 methyl groups. So it is not chiral because those 2 are the same. Let's go to this molecule. As I always do, I'm going to change it to a line angle structure. 2 carbons. One of them has 2 chlorides on it. So we've already ruled out the side with 2 chlorides, and this side with its 3 hydrogen, not chiral as well. Let's go to this molecule, very similar. But now one of the chlorines is replaced with a fluorine. Now we've got a methyl group, a fluorine, a chlorine, and an implicit hydrogen. This has 4 different groups. So we could highlight it and say this has a chiral center. Let's go to the next example. Any of these here with a double bond only have 1, 2, 3 things. I can draw the implicit hydrogen, 3 things attached. They are not going to be chiral with only 3 things attached. You can draw a mirror plane through it if you're wanting to think about symmetries. So we can rule out all of these carbons around the ring. Let's move to here. This has 2 hydrogen attached, not chiral. Out on the end, another methyl group with 3 hydrogen, not chiral. So we've only got this spot left to check. It's got methyl. Well, it's got the hydroxyl group. That would be group 1. It's got this large piece of molecule here. That would be group 2. It's got another methyl group there, 3. And then the implicit hydrogen would be the 4th group. So this is a chiral center. Let's look at these molecules. Superficially, their line angle structures all look the same, really similar. This one down here, we can tell it has no chiral centers because this benzene ring is totally flat. All of these have just 3 groups attached. And this methyl here has 3 hydrogen. So this molecule is achiral. Let's move up to this top one. We can rule out all of these methylene groups, these CH2 groups. None of them are chiral. This methyl group out here is not chiral, so we've only got 2 carbons left. This one here that the methyl group attaches to, and this one that the hydroxyl group attaches to. So if we were numbering these groups, the hydroxyl group would be group 1, going this way would be group 2, going up around the ring would be group 3, and then the hydrogen that we can't see is group 4, and that's a chiral center. This one here, the group headed towards the oxygen would be group 1. The group headed around the ring the other way would be group 2. The methyl group would be group 3, and the hydrogen that we can't see is group 4. This molecule has 2 chiral centers, and we circled them there. Let's look at this one here. It is very similar. They're both cyclohexanol with a methyl group. They're both methyl cyclohexanol. But in this one, we've got the OH group. That's our first group. Our second group, we start going around this way, and it's identical to going around in this other direction. So these, we can't tell them apart, and this is not a chiral center. And the same would be true over on this side. So this second molecule is a chiral.